haven't met me, I'm Dr. Stanhope, and I am the course director for this class this semester. So I'm actually really excited to introduce you guys to Calcplot 3D. For those who may have taken the course in the past or who have talked to other people who have taken the course in the past, we actually only used to let students use Mathematica. Calcplot 3D is a new technology we're allowing in the course. So at first thought when I said, oh my gosh, now I have to learn 2 things instead of 1. But actually we are trying to lighten the load for all of you. Visualizing in Mathematica is challenging, okay? And the list of commands you have to learn in Mathematica has now been cut to drastically less by using Calcplot 3D. Okay, so Calcplot 3D, I'm marketing it as our visualization tool for Calculus 3. Mathematica is our computational tool. While you can visualize in Mathematica, we're not going to go over that in today's lesson because, in my opinion, it's much easier to do it on Calcplot 3D. So if you have questions that arise throughout the workshop, just raise your hand and we can address them. And if you could just follow along with me, I think clicking through things instead of just watching will help you remember them at a later date. So if everyone could please go to the Calcplot 3D website. You should all have it bookmarked in your browser. That was one of the checklist items. If not, you can access it on the platform. We actually will require you to save an offline version of Calcplot 3D onto your desktop. You're going to do that in class next week. Your instructor will walk you through it. Okay? So for now, we'll just use the one connected to the web. Alright, so when you first open up Calcplot 3D, every single time, this is what you're going to see. Okay, so it provides an example. So to get started, let's just go ahead and get familiar with some of the buttons that we'll encounter. Okay, so let's start up here at the top. So this is a refresh button. If you want to start over, that would be the button to hit. Or if things start early for some reason, you want to start from scratch, just refresh the page. This deletes everything from the graph while still keeping all of your equations here. The other way to get things to appear and disappear are just with the check box here. Okay, that adds and deletes whatever is added to the graph. You can add multiple things to one graph or just one. So let's go ahead and walk through a few things with this example surface that they have plotted here. So other tools up at the top are zoom in and zoom out. So this is another great feature. In Mathematica, you would have had to try to guess which window you wanted to see it in and alter it until you got the right one. Here, it's pretty easy to zoom out and zoom in with the hourglass icons. So we won't really be using this button. This turns it into a 3D graph. So if you have any 3D glasses at home, you could look at it in 3D. That actually looks pretty cool. And this creates a more transparent surface. This button removes the edges. This button removes the faces. So actually, you can learn a lot about Calcplot 3D by just clicking around a bit. That's one of the reasons I like it so much, is that it's pretty much self-explanatory. Okay, so I'm just going to give you a brief introduction today so you can see some of its capabilities. But really practicing with it, playing around, you'll get to learn it pretty well. So let's see some of the other things we can set. If you notice that as I zoomed out, the surface started to look pretty faceted and kind of square rather than smooth. If we wish to change that, we can by increasing the number of grid lines here. So I could, for example, increase this to 50, and we can hit enter. Anything we change, we should hit enter afterwards for it to implement, and we see that it's smoothed out. Okay? All right, so if you, for example, we've seen we can change our view by zooming in and zooming out, but let's say you only care about this surface in the first octet. Okay, you can set that view with this icon. Okay? So if I click this once, I can now set my window to exactly what I want to do if I wish. Okay? Oftentimes, zooming in and zooming out gives me an of an idea of what I'm working with. But if you, for example, want to see only the first octant, we could make all of the x, y, and z minimums to 0. And nothing happened, right? I need to click enter for this to be implemented. All right, so there's my view in the first octant. And what's really nice about this applet as well is that you can rotate these figures to really get a spatial understanding of these objects. So there are two ways to rotate. One of the easiest ways is using the left and the right arrow on the keyboard. Okay, so if I press the right arrow, I kind of rotate around like that. Also, we can move the object. So if you notice, it's kind of going off the screen up top. If I want to zoom out, I can just, well, on my machine, it's 2 fingers to zoom in and zoom out. Also, I can right-click and move this somewhere else. All right, and then, as I said, the left and right arrows can rotate this around in 3 dimensions and up and down as well. So we can really get a nice understanding of what object we're working with when we rotate it around. You can also click it with the mouse to rotate it, but sometimes it doesn't move exactly how you would expect. So I find the arrows to be a little bit easier way to rotate the figure around. All right, so the other items here you probably aren't going to need to mess with. Here are just the tick marks if you want them to be incremented every 1 instead of every 2, for example. Upper and lower z clip is just clipping the graph at that upper and lower z value. And so I could clip this here at x equals 1 if for some reason I only wanted that portion. But I don't imagine that you would be using the z clip that much. So to get this to go away, you just press that same button. Okay? Clicking it once makes it appear. You can edit it. Clicking it again makes it go away. Okay? And there is this box next door, which you may or may not wish to use. But for example, we can get rid of the box if for whatever reason you don't want to see that, and things like that. But you likely don't want to use that one quite as much either. Okay, questions up to this point? So let's practice plotting a few things that we're going to be using frequently in this course. So for example, we're going to be plotting a lot of surfaces in this class. So I think you all are really, really lucky that you get to use these tools. At the other institutions I've taught at, these students have no use of technology in Calculus 3. And I was taught as a student as well. When that happens as a student, what I hear from students in those settings is that I can't picture it. I don't know what I'm working with. I can't draw it. And so I'm really excited that you guys have the opportunity to visualize all of these things that we're working with. So, for example, in this class, maybe we're going to graph this surface. This is a paraboloid. So if I wanted to graph this surface, I have one of 2 options. So I'm going to go ahead and delete this item by clicking the X here. You'll see everything's pretty self-explanatory here. Add to the graph. So here's my drop-down list of items that I can plot. From this drop-down list, in this course, you're really only going to be doing a couple of things. Right? You're going to plot a function that's solved for z. That's the surface. You are going to be using the space curve option. Later in the course, we'll be doing vector field, so right under it. If you wish, you can add a point or a vector. The only other one we're going to use is this implicit surface, and that's it. Those are really the only ones you're going to need in this course. And as you go through the lessons, hopefully your instructor will model it for you during class, and you'll get to see how to use it there as well. So for a surface, we have 2 options. option 1 is the function z as a function of x and y. And option 2 is implicit surface. So when do you use which? Well, actually, implicit surface will work every single time. So if you want to just use that as your default, feel free. If the function can be solved for z, as in this case, you can feel free to use that other function. So what is an implicit function? An implicitly defined function is something like the following. X squared plus y squared plus z squared equals 1. What kind of surface is this? Sphere, centered at the origin of radius 1. Awesome. So over time, you'll get to recognize these if you don't already. This cannot be solved for z in a way in which we come out with one equation. Right? So this is an implicit equation, so we would certainly want to use, we would only have the option of using the implicit surface. All right, so feel free to just default to the implicit surface every time to graph a figure. So let's try one out. So why doesn't everyone click implicit surface? So every time you choose something from this drop-down list or add to graph, an example is already there for you. Okay, so you're going to have to delete it out. I mean, you can look at it if you wish by clicking the check box. This might help if you forget which item from the drop list does what, right? You can look at the example and say, oh, this is graphing the surface. Okay, but either way, you're going to have to delete it and start over. So let's go ahead and just graph the sphere. So if I type in here x squared plus y squared plus z squared equals 1. And just like you might have experienced in other classes, this caret is used for powers. So that's how we denote to the power of 2, for example. And now if I click enter, I'll see my sphere here. Okay. All right, and again, if I have other things I want to add to the graph, I can simply add them by selecting the drop-down list and picking another item. All right, so the other thing, so let's get rid of that sphere. We're also going to be adding space curves. So if you're an M-Day student, you covered equations of lines today, so we already know what a vector equation R of T is. If you're a T-Day student, you're going to see this tomorrow. So one thing we're going to be graphing is curves in R3. So if we click this button, let's go ahead and just look at their example. So if we click the checkbox here, we can view the example that's provided. And it's a helix. Okay? So there it is. We can rotate it around and look at it if we want. Okay. So within this example, we have an equation for x, y, and z, and they're all in terms of the parameter t. So we also would need to set our range of t values. Here it's plotted from t equals -10 to 10. So we're only seeing a portion of this curve. We could decrease this, for example, from 15 to 15 if we wanted to see more of it. And if your curve starts getting choppy looking for some reason, you could increase the number of steps here as well. Okay. So in this course, we're going to be working with curves in 3 dimensions as well as curves in 2 dimensions. So I can change this. Let's say instead of this curve, I'm actually only looking at the 2-dimensional curve, cosine of t, sine of t. Does anyone know what this implicit function looks like?
Circle.
It does, I agree. So here, these parametric equations are a circle. So if we have a curve that we want to graph in R2 instead of R3, we're just going to set the z component to be 0, right? So that it lives on the xy plane. And clicking enter, there it is. But if I really only care about this in 2 dimensions, I may as well look at it R2 framework. So down here, I'm going to restrict the view to 2 dimensions. And so now I can look at this curve in R2. And this is another time when values of t that I choose might be interesting. So in order to trace this curve out once, we would be looking at, so it's fine. Oftentimes we just want to get a view of it, but just to show you what the different values of t would give, if we range t only from 0 to pi, and pi we just type in as pi, that's the top half of the circle. And if we range t from 0 to 2 pi, you get the entire circle. So a lot of these things, the mathematical part of this will become more clear as we move along in the course. But at least now you know how to make a picture of them, either in R2 when we have 2 equations, or in R3 when we have 3. All right, so another thing that I want to just point out quickly is how to plot a point and a vector. I'm just going to refresh to start over. Sometimes if you switch to the 2D view and you add something and you want to get back to the 3D view, things might get a little strange in the window, so you can just start over. All right, so I'm going to clear everything off of the graph, and I'm going to add a point. So it's just like you might imagine. That's the beauty of this program, is everything's point and click and fill in the box. Right? So here we can add this point onto the graph. Maybe you're interested in finding the equation of a plane that goes through 3 points, and you want to look at those 3 points in space or something. You can add a point. You can also add a vector. So here, if we wanted to add a vector, again, go to the drop-down menu, and choose vector. And I can graph any vector that I choose. So if I want to graph the vector -1, 1, 1. Oh, interesting. That's the same point I just plotted. What's this vector going to look like in relation to the object already on the graph? Exactly. Pinned at the origin with the tail, and it's going to point toward that point. So I can add that on. We understand that relationship between vectors and points. This is a guide of how to get from the tail to the tip. With -1 in the x, 1 in the y, and 1 in the z. And that's exactly how we get to plotting that point as well. Okay, and you can make these vectors whatever color you wish if you choose. Okay. All right, so I think that you can think of creative ways to use Calplot 3D to check your work. So let's say, for example, you're doing a problem where you're given the equation of 2 planes. And your task in this problem is to find parametric equations for the line of intersection between these 2 planes. Okay, does everyone agree 2 planes cross in a line? Yes. Or they're parallel? Those are our options. So let's get a visualization of that. So for example, let's plot the following 2 planes. Let's plot the plane x plus y plus z equals 1. And let's also plot the plane x minus 2y plus 3z equals 1. Right, so get those on your graph. So what am I choosing in my options? Implicit surface. So let's plug it in. And then to get another plane, I just go back to the drop-down list and choose another implicit surface. And I'll delete their example and put in my plane that I wish to look at. If I hit enter, it appears. All right, so here's the 2 planes. I can zoom in or zoom out if I wish. One thing I notice is that the intersection between these is kind of ugly, right?
Yeah.
That's not very visually pleasing. So what we can do is change the 3D mode. right here. If you click it 2 times, the image becomes much nicer. And so we can clearly see that the intersection of these 2 planes is along the line. So did everyone see how I made the figure look nicer? I clicked this 3D mode twice. I don't know why it's not just set to that mode automatically. Maybe it's too difficult for some, if you add a lot of things on, maybe it takes too much memory for a cell phone. By the way, you can use CapCut 3D on your cell phone. Not during the VR. All right, so there's our 2 planes. We can control a lot of things about them if we wish. So for example, if I go to this gear, I can change their transparency if I wanted to see through them. I can use a constant color and pick that color if I wanted to. Okay, so this was all in a little gear, but often you won't need to use these options. All right, so you're gonna learn how to do this, I think this week, but you can find the line of intersection between these 2 planes. So we're gonna skip the math and I'll just spoil it for you. The line of intersection is R of t equals 1 plus 5t, negative 2t, and negative 3t. After lesson 6, you can try this on your own and make sure you can do it as well. But I can check my own work by using our visualization tools. So maybe I'm on the GR, about to the end, I have a little bit of extra time. I can make sure I got the right answer on this question, right? So what am I going to do? Space curve. Space curve, exactly. Let's add it in and see if it lines up the way we want. Okay, so let's add a space curve in there. Thanks, Britt. So here we go. 1 plus 5t. Negative 2t, and the y, and in the z, negative 3t. Hit enter. So you can rotate it around. Looks like we did a good job. So I know that I got this answer correct. Maybe in another application, we want to add a vector to the curve. So why don't we take off? So was everyone able to get that line on there? Awesome. Why don't we take it off and take the other plane off? So here I just have this first plane graphed at the moment. For those who are an M-Day student, normal vector to that plane. Or T-Day if you read ahead. I'm asking for the normal vector of this plane. 1, 1, 1, 1. 1, 1, 1. You read it off as the coefficients in front of x, y, and z. And a normal vector is a vector that's perpendicular to the plane. So if I wanted to visualize this, I could add in a vector. So here, going to the drop-down menu, I can add in a vector. And here I'll make it the vector 1, 1, 1. And maybe I'll make it red so it stands out, and add it into the graph. Okay, so I can see that this indeed is perpendicular to the plane. If I wanted it to emanate from the plane instead of from the origin, what do you think I would do? I would need to move it. Oh, maybe I didn't think this through. So I can make this vector emanate from anywhere that I want by changing the initial point. Okay. At the moment, actually, we have to do some calculations to figure out what that point is. But just so that you know, we can move this to emanate from any point. So for example, if we wanted it to emanate from the point to this point for some reason, we can move our vector anywhere we want. And it's still the same vector, right? Yes. I didn't change my guide from the tail to the tip. I just changed where it's emanating from. So I didn't change its length or direction. So this vector is equal to the vector 1, 1, 1. All right, so these are the type of things that you're going to be doing with CalPlot 3D this semester. There are a couple of things that I didn't talk over, just, for example, creating a contour plot, but that will come in time in class. But this is a good way to get started. with this tool. So I highly encourage you to try to visualize the problems you're working on, check your work, and get comfortable with this because it is an authorized resource on all of your GRs in your final exam, okay? And that APS is in place. All right, so any questions before we shift over to our computational tool, Mathematica? So are you finding this program to be pretty self-explanatory?
Yes.
Right, that's the beauty of it. So we're trying to make life easier and a little less clunky than the Mathematica visualization. So hopefully you like it.
So ignore all the icons on my desktop. And let's launch Mathematica. So I'm assuming you all have it installed, right? Okay, good. So it should be under your Wolfram if you don't have it pinned anywhere, which I don't, but I'm going to launch Wolfram Mathematica from the menu bar. And you'll see some messages that scroll by really quickly. One of them is initializing kernel. So the kernel is kind of like the brains of this program. It's where you store things in resident memory. It's where computations occur. Okay? And why am I telling you that? Because the kernel can get kind of confused, or at least your notebook up here. And how it talks to the kernel can be confusing. They can trip you up on various occasions from time to time if you're not careful. Okay, so as we work through this workshop, I am going to do some things deliberately incorrectly. Because there are things that I see that incorrectly. So I want to just magnify that for you now, and so that you can see what the correct way to do it is. Okay. So I'm going to try to point out all those salient points as much as I can, so that you can get off and running with this tool very, very quickly. That's the whole point of the workshop. Okay. So what we're going to do now is open up a new notebook file. So let's see, who has a notebook? Good. Okay. So Mathematica is a Windows application, right? It's like opening Microsoft Word, opening Microsoft Excel. Whenever you open it up, and you see the basic functions. You can open a file, right? You can save a file, that kind of thing. The basic file structure is called a notebook, right? So if you open this notebook, I'm open to a blank page. Right? This is what you have in front of you. If you have a pen, pencil in hand, and this notebook right on your desktop, right? So how does this piece of software mimic this? Well, you open up a file. Thank you very much. We're going to select new document. You can see there's a list of recent files beneath that. You probably don't have any of those yet, but you will as the semester progresses, right? So we're going to select new document, and it opens up a page to our digital notebook, if you will, our digital Mathematica notebook. Okay, so just like you write down Cal 3 equations on your notebook in class, I'm sure you all take really good notes, right?
Of course.
Oh, yeah.
Yes, sir, I do. Yes, sir, I do. I'll answer for you fast. All right. So you see a blank page here, right? This is your piece of paper. And your mouse, right, or your touchpad on your computer is going to be your writing instrument. Right? Now, it's not quite that direct, but basically what you have here is a notebook file, right? So you're going to be doing all your computations, all your inputs on this file. All right, now let me encourage you now to save this file frequently. The last thing you want to do, and I'm emphasizing this right now because I've seen it happen probably hundreds of times, is that you actually work through trying to solve a problem in Cal 3, and I'll input maybe several dozen lines of code, and then the kernel crashes or their computer, laptop, whatever crashes, and they've lost everything and they've got to start. Right? So like anything else, just like you're typing a history paper or something like that in Microsoft Word, you're going to want to save early and save often. Okay? So let's take a look at this notebook file. I'm going to go ahead and expand this, make it full screen. I want you to look at the top left here, and what do you see?
Plus.
We'll tab with a plus sign, right? This is an input tab. Plus means I want to add something to my notebook, okay? So what do you want to add to the notebook? Well, you want to add either some equations perhaps, or maybe you want to add some text, right? So let's put a header of text on this so that we can identify the purpose of this file. So if I left click on that plus sign, I can choose the form of my input into the Mathematica notebook, right? So if you look closely at that menu, we're going to choose plain text. Really, the only ones you're going to use are free form and plain text. Really, the only reason that you have to use any of those two. But so we're going to type in here the name of this document. So let's put in QRC introductory. Well, let's put in QRC workshop first. Introductory techniques. And beneath that, I'm going to hit enter. Facilitated by yours truly. And now let's put the semester on here too. Fall. You can format this if you want, so let's go ahead and format it and highlight this. And come up to format, and you can format it however you like. Let's just choose something fairly large, say 16. And let's change the fonts. Let's just do text color is okay. Black. Let's do boldface. All right. And then we'll maybe make that a different color. Now, I want you to left click beneath that. Now, I want you to look to the right side of the notebook here, and you're going to see a fairly large bracket on the right-hand side. This is called a cell. It's an entry cell. The entry was plain text, right? And we're going to do some examples of not plain text right here in a minute. But that is called an entry cell. And every entry that you make in your notebook file will have its own cell. And there will be instances where you may want to delete cells because maybe you made some mistakes and you don't want to see those mistakes anymore. And I'll show you how to do that as we move along. Okay. Now, the default entry is what's called freeform. So if you left click on that, freeform input, you don't have to click on the freeform input, but if you just left click, again, in the open space, beneath that first cell, you're basically free to enter something. Okay, what do we want to enter? Well, let's just start defining some things. Let's define some variables. Okay, so again, follow along with me. Okay, so do what I do on yours, and if you get wrapped around the axle or something, you can raise your hand, back your stand up, and come around and just kind of work your way around through. Okay. So let's take a variable. Let's say A. And for your sake, before I go any further, we're going to go to the window menu and we're going to magnify this for the benefit of especially the folks in the back of the room. All right? How's that? Is that better? Yeah? Everyone in the back row can see? Okay. If you think we need to make it larger, just let me know. Okay? Let's assign the variable A a value. Let's say 5. Okay? So we're going to say A equals 5. Okay? Now I want you to make note of one thing. Actually, two things here. We used a single equal sign. And what is the color of the variable A? Blue. Okay. Now, what do we want to do with this? Right? So you remember this thing I mentioned earlier called the kernel? Kernel. So the kernel of Mathematica is the brain. It's where it's going to store things in memory. Okay. So how do we put the variable A into memory with the assigned value of 5? There's an action that we need to do with the keyboard. And to do that, that is Shift Enter. So do that now. Shift Enter. Okay, you should notice several things here. Maybe 2, 3 things. Did you notice what changed on your notebook?
It recorded it.
Okay, so it recorded it, right? So it's now in Mathematica's memory as the value 5, right? So what did you see on your notebook that actually changed? Okay, went from blue to black, right? So what do you think blue means? Unassigned in kernel memory. Okay, good. What else did you see pop up here? Okay. An input and an output line got labeled, right? That's probably a good thing. What do you see on the right-hand side? Yeah, another cell, right? And they're in the subcells. One subcell for the input line, one subcell for the output line. Okay? Let's define another variable. Let's say, I don't know, you guys pick a number. 12. Right. Let's do, by the way, before we do that, if I wanted to recall this variable A from MMA's memory, in other words, I just type A there. All I need to do is hit Shift Enter. Right? So MMA says, okay, yeah, that's a black variable. I've got that stored in memory, and here's its value. It throws it right back out at you. Right? So maybe you've got, I don't know, 3 dozen lines of code in there. You're working on some complicated calculus problem. And you want to know what is the value of the variable C, right? Or X or whatever. All you need to do is just type it and Shift Enter. Now, how about some other variable? What if we take the variable, let's say B, right? And I hit Shift Enter. What does MMA do? It throws it back at you and says, yeah, B is B. That's what I know B to be. Right? B is B. It doesn't know it as anything else. But 12 was suggested, so let's assign the value of 12 to the variable B. B. Now, one thing you might have just noticed is that every time you input something, you want to assign a variable some value, and you hit Shift Enter, it spits the output back at you, right? It did that for the assignment of A, value of 5. It did it for B is 12. You can suppress the output if you want. Now, I'll say a word about that in a minute, but the way to do that is to just put a semicolon after the value that you want to assign, and hit Shift Enter again, and it just suppresses the output. Maybe we can do another variable. Let's do C is equal to 20, right? And then we'll put a semicolon there. So C is blue because it's not been assigned yet, but as soon as I hit Shift Enter, I see that blue C turn black. But the output has been suppressed. My advice to you, free advice, you don't have to do this, but in the effort of encouraging good habits early on rather than developing bad habits early on, I would not use the suppress. Maybe you can use it later on in the semester when you feel a little more confident in using this tool. Right now, I think it's good because you're on the mathematical learning curve to leave out the suppression so that you get confirmation immediately that MMA has done what you expected it to do. Okay? All right, let's do some simple arithmetic. Let's do, before we do that, let's do a couple more things on variables then. Suppose I want to name a variable D1. Do you think I can do that?
Yeah.
Yes.
Yes, you can.
Yes, you can. So you can use an alphanumeric character string, a combination of letters and numbers, to define. Let's do 25. You think it's case sensitive?
Yeah, yes.
It is. So maybe we do capital B. Capital B is equal to, let's say, 11.
So what is it, the sum equals, like, the sum of one actually doing?
It's suppressing the output.
So what does that mean?
So take a look. If you look at input line 4, so input line 4 is right here. There's no semicolon, right? So that means there is an output line of the same number that is displayed, right? Here, we did input line 5, b equals 12, and we suppressed it. So there was no out 5 line following it. So
Like,
it's
will it
suppressed.
still remember it?
Oh, yeah. How do you know it's still remembered? How do you know it's still in the kernel memory? It's because it's changed colors, right?
So it's what would be the point of suppressing it?
Because you're going to find that when you start inputting many, many lines of code, you may not need, yeah, right? You can declutter things. Again, you'll navigate certain waters. I will tell you this, in the thousands of EI sessions that I've given in Mathematica, there are no two identical Mathematica programmers. Everyone has their own style, their own, what works for them. Right? What works for you may not work for someone else. But you got to navigate those letters and learn what works for you. And what I mean by that is what helps you execute in Mathematica. And if you're not sure about that, talk to one of your instructors. Come and see me. He's happy to help you navigate this one. Let's try this one. D equals 100. Oh my gosh, what happened? It's, what does it say? It's protected, right? D is protected, capital D. Right? So, you can't use it. You cannot use that. Right? It's already reserved for something else. Anyone want to guess what D might be used for?
Derivative.
Derivative, yeah. Yeah, so there are functions in Mathematica that allow you to do different computations, and differentiation is one of those. We're going to do that here shortly, right? But just be careful that there are some symbols that are reserved in MMA already that you cannot use. It means you just have to use something else, right? The error message you receive will look something like that. Okay. Let's do this one. Let's do a variable called xy. Now, we can use, we said earlier, we can use alphanumeric strings, right? So I can use more than one letter if I want to define a variable. We used D1 earlier, but how about xy? Okay, well maybe let's set that equal to 200. Shift enter. Okay, that's okay, right? But what if I want to use a function, maybe a multivariable function like this here, that has an x times y? I can't just say xy, right? Because MMA is going to interpret that as a single variable. So when it comes to multiplication, you have to use the asterisk. So let's take a couple numbers that we already have. Let's say A and B. So let's do A times B. So this will be A asterisk B shift enter. So B we said was what? 12, right? And A is 5. All right, so did MMA do the math correctly? Yeah, absolutely. Yeah. Now I could store that in MMA's memory if I wanted to. I could say product equals A times And if I want to recall the value of product, I do that. Did you see what happened over there? What did you see there?
Oh, it's dropped down.
Yeah, it's a little drop down. So MMA can remember some things that you already type in, that's already stored in memory. And based on the unique characters that you type here, it will throw them out in a little pull-down menu, and you can select which one you want. You'll see that feature quite frequently, actually, when you start getting into really using this tool. That's multiplication. What do we want to add A and B? Well, real simple, A plus B. Shift there. Okay. All right, any questions so far? Let's do a couple, instead of just pure number assignments, let's do some functions. Let's do D2 equals, let's do an exponential. Let's do 24 e to the third power. So 24 times asterisk, right? Now, e to some power. We want e to the third in this case, right? So this is what we want. This is what we want mathematics to evaluate. 24 e cubed. There's a couple ways you can do this. I'll show you. The first way is exp. Notice, exp is capitalized with the first letter e. Right? This is a function. All Mathematica functions begin with a capital letter. The argument that you pass to the function is always in square brackets, like you see here. So what do we want to put inside the square bracket? 3. Okay? Shift, enter. 24 e to the third. There it is. Now, there is another way you can actually input. That is using something called the palette. So if you look at the menu on the top, go to palette, and select Basic Math Assistant. It will pull up a graphical user interface over here with various mathematical functions. Right? So if I want to, I can do this again. And I'm going to go ahead and type it again here in the next 24 times, where is the exponential on this guy? It's,
What did you click to get on?
what's that? Over here. Palette menu. Basic math. Where is it, guys?
Top right corner of the documentation.
All the way where?
Top right corner of the
Top
documentation.
right. That guy?
Yep. Oh yeah, it is. Because that's.
Forgot my reading glasses. Okay. And we want to put this guy, we want to put power 3. So let's see, where is that? There should be a function e to the power. In the middle, elementary function. There it is, that one? Yeah, that's the one I want. So let's go over here, take the first one out. And in the EXPR box, we're going to put 3. Okay? Shift enter, right?
Does it matter that you choose the first or?
Yeah, and in that case, you know, you only select, if you want to use this without an exponent, then just use that. If you want to use some power, like what do you use?
So if you put here the automatic.
Yes, it will fill it in on your input line. Okay, now, my next question for you is, what do we want this in decimal form? How do we do that? There's a couple ways you can do this. There's another Mathematica function that you can use called capital N, which means evaluate numerically. So N, it's a function, so we use square brackets. Now, let me give you a little insight into my style of input and programming. Whenever I'm using a function, I automatically put in the opening and the closing square brackets. And the reason that I do that is because in Mathematica you can embed functions. And there may be times this semester when you want to embed functions. There'll be plenty of opportunities to do that actually. So you're going to have multiple brackets, right? So if you just start typing left to right, you can get in kind of a bracketology mess sometimes. And I've seen cadets doing that where they're trying to count brackets. I don't know how many brackets they have. But for me, this is again what works for me. You have to find what works for you. I put the opening and closing brackets in right away. So that way I know. I've already closed it, so now I can just go inside and input whatever I want inside of it. Now, what do I want to evaluate? I want to evaluate numerically what is on the previous output line. Okay? How do I do that? There's a couple ways you can do that. You can actually say out. What line is that? 16? You could do that. Or you could do something a little simpler and say n percent. And percent means give you the value of the previous output line. And in that case, that's not a good example. I should have done 2% because the previous output line is already in decimal form. But if I go to this one, out 16, which is the second. So if I do 2% signs, it means go up 2 output lines.
That's E, but the variable function.
Right? Obviously, I'm still going to get the same answer. Right?
No, I think it's a different E.
There's a couple other ways you can do this. You can copy and paste here, by the way, folks. So I'm going to highlight this. I'm going to do a Control-C. And I'm going to take it down to my next text. And I'm going to copy it. Control-V. And I'm going to use a double / capital N. Double / capital N says take this and numerically evaluate it. So you shift enter. You're going to find this very, very powerful, by the way. When you want to get things into decimal form right away. You find a lot of use for that. Especially when you want to calculate some integrals. Double integrals, triple integrals, you want to get a numerical value. That would be very good. Okay. All right, any questions so far? Everyone following along well? Okay. Now, let's put in a comment. There's a couple ways you can put in a comment. You do it like that. Parentheses with 2 asterisks here on your side. Or you could go to the plain text and put here. Either way is fine. Now, I'm going to go ahead and close the math palette here for 1 second. And I want to back up to a previous input cell. And I want to remove something. So let's see. What do I want to remove here? Let's take this one out. Right? We defined D2 in 2 places, right? We just did it using 2 different forms. Okay? So what I want to do is I want to take input line 16 out. So I move over to the right here, and I find the corresponding cell, which is this one right here.
That's 17.
It's not. You're right. Thank you. It's this one. don't ever forget your reading glasses. None of you use reading glasses. Not yet. All right. So notice when you left click that cell, it highlights blue. Just go ahead and hit the delete key and it will delete it for you. So if you want to clean up your code a little bit, maybe some things got kind of messy along the way when you were working through some steps of a computation, right? That's going to happen. That's going to be a common thing, right? But it's like cleaning up your paper. You want to erase some stuff that you maybe scratched out, right? You just erase it. Right? So this is no different than that. Okay. Let's take a look at a few more Mathematica functions. How about the trig functions? Okay, so what do we say? What are the two rules about the format of Mathematica functions? Okay, always begins uppercase, square brackets. All right, so what do you think of cosine? Okay, now, we need to input an angle, right? Mathematica likes units of radians, not degrees, right? So if I put in something like 180 and hit Shift Enter, it says, hey man, I don't know what that is, so I'm giving you right back what you typed, right? So if I want to give 180 degrees in radians, I would say cosine of pi, pi, capital Pi in Mathematica. That is reserved, that is protected, so you cannot create a variable called capital Pi. Cannot. Right? So enter that in the cosine function and hit Shift Enter. Did I do that? Ah, I added the wrong line. Interesting. So let's do that. -1. Right? Does that mean you cannot use degrees? You can, but you have to tell it that you're using degrees. So if you do want to say 180, you have to type in degree. And here's another one of those instances where Mathematica is trying to predict what you want. All right? So you can just select that if you like from the pull-down menu. Shift Enter. If you wanted to store that in memory, that'd be fine. You could put a variable in front of it. Right, just store it in memory. So, sine function is what? Capital S. Capital S, sine, and brackets. Okay, pretty straightforward. By the way, let me advertise also, as I did for the CalcPlot 3D tool, the help menu for MMA. It is quite good. You can learn. How many of you learned through examples? Yeah? Okay, well then you're going to find the Mathematica documentation very, very handy. So if you select that Wolfram documentation from the help menu, you will see this page come up. And if you want to browse by category, you can, but you can also type in, if you know the name of the function, right? Or maybe if you think you know what you want to look up. Maybe you're not sure what the percent is. You can just type in percent and then hit the search bar and it's going to tell you what the percent sign does. I'll tell you how to do that. If you want to know about the cosine function, type it in. Okay? Gives great examples all the way down the list. All right? So again, don't be shy about using the resources here. Okay. All right, let's move into showing you how to clear a variable from MMA's memory. All right, maybe you want that A variable back, right? Well, there's a function called clear. No surprise there, right? So if I do clear A, like that, Shift Enter, and notice the A was black there, right? Yeah, now turn it blue. And if I type A and hit Shift Enter, MMA's It's erased the 5 that we assigned to it earlier, right? Yes, sir.
Assign like a new value directly, right? You say like a equal 5, like 6, and you'll assign like the new.
Yeah, you could do that as well. But suppose you have, several problems you're working on, and maybe you're working with surfaces and surface functions, and you have a surface of a parabola that you're using, and then maybe a surface of a sphere, and you want to preserve your x's and y's and things like that, one problem to the next. It's a good habit to do a clear. Okay? So if you want to clear all the variables, there's a command called clear all. All right, and if you do this one, you got to be careful with this one. Clear all. Let's see. Here. Global. So there's double quotes, global, and then you're going to do a single quote, asterisk, double quote. That's going to clear everything. I'm not going to do a shift enter here because I still want to use some of the variables that we assigned before. So if you really want to clean it out, it's going to clean up trouble.
If you delete the sub after, does he search everything back?
Does it what?
If you like press like everything,
Yeah.
and you delete this sub, does he
I will not delete the session.
I don't think they come back.
No, they don't come back.
Because I like deleted one of the like A equals something, and it was still the variable, it goes back to that variable. It's done.
Okay, so what I'd like to do now, so let's step into some functions. All right, so we've just basically done, some basic arithmetic, how to assign variables, some do's and don'ts, and things like that. So let's put in now, let's put in a heading here, put in some single variable functions. Yeah, and I'll go ahead and we'll boldface this, like so. And then we'll left click beneath it off to the left and get us back into our input mode. So, single variable function. F of x. So let's do 2x to the 4th minus 4x cubed. Okay, so let's go ahead and define this function. So how are we going to do this? Well, let's use f. Okay, it's blue. We haven't used it before, right? Now, notice something we're going to do here. We're going to put square brackets here. And inside the square brackets, we're going to put the variable x. So that kind of looks like this, right? Okay, but after that x, we're going to do one thing. We're going to put x underscore. Okay, equals, and let's go ahead and code this in. 2 times x to the 4th, so 2 asterisk x, how do I do a power here? Raised to a power? So I can do a 4 exponent by using the parent. So x raised to the 4th minus, what did we say? 4x cubed. So 4 asterisk x carried 3. And now I can hit shift enter, like so. And there's my function. These are lowercase x's. Now, why do we put this underscore here? We put this underscore here because we are defining the function f of x here. If I leave that off, in other words, if I just did something like f equals 2 times, well, let's do another example. Let's do a g. We'll do a function called g, and I'll just define it as the same thing. So times x 4 minus 4 times x raised to the 3rd power, and I hit shift over there. So I can now ask the Mathematica kernel, what are my values of f of x and g of x? Well, if I just hit G and then shift enter, there it is. And if I hit F and shift enter, look at that. But now if I do f of x, shift enter, I've got that.
Does it not matter for underscore?
It matters. You need the underscore because you're defining a function. That's the rule. It's the only time you're going to use the underscore is when you're defining that function f of x. If we want to recall that function later on, and we can do that as an example, you would just call it f of x in square bracket. I'll show you how to do that. But the point that I'm making right here is the following. If I want to evaluate this function f of x at some value of x, and you'll have plenty of opportunity this semester to evaluate functions that you're going to put into MMA. How do I do it? Well, I just do f bracket, let's say we want to evaluate this at the value of 2. Shift enter. You get 0. Let's evaluate it at some other value. Let's do 4. 256. Right? Let's try it with G. So what is G of 4? What did MMA do here? It threw G back out at you. There it is.
It's multiplying the function.
And then it's saying, I'm going to throw bracket 4 back at you because I really don't know what to do with this. So the value, when you define a function, is f underscore of x. It's allowing you to substitute in a value for x and evaluate that function at some later time. Okay? Now, if I want to define a new function, let's say h of x, getting back to what we wanted to try before, where I recall f of x, maybe I want to do, let's say multiply it by 1,000. So I'll do 1,000 times f of x. Well, notice here, I did not put the underscore there because I'm not defining f of x. F of x is already defined. It's the only time you want to use the underscore is when you're defining the function. Right? So what am I doing here? I'm defining a new function, h of x. So I do need the underscore there. Don't need it there. So if you hit shift enter, what did you see?
Doesn't size the function.
Yeah, so that's my new function. So now if I want to evaluate h at a value of 4, let's say, just do h of 4, this, and shift enter. And it takes my value of f of x, which I had previously as 256 on output line 32, right? I can do that simple math in my head. I know 256 times 1,000 is 256,000. So I'm going to make it correct. So these are some pitfalls that we try and emphasize in this workshop that I don't want you to fall into, right? So start the good habits now, and it'll save you from breaking bad habits later. Anytime you want to define a function, f x underscore, right? Or g of x underscore h, whatever. Okay, here's something else we can do. Let's see, do we have b defined? Let's see. Yeah, b is 12. That was one of your suggestions. So I can evaluate f at the value of b, whatever the value of b is, right? By putting in a variable. Getting the hang of this? Okay, good. Now, let's step into the world of Calc 3. This is all Calc 1 stuff, right? This is y equals that. Right? So maybe we do this. Maybe before we step into the world of Calc 3 with multivariables, that, let's take the derivative of this. So let's execute the derivative. There's two ways you can do this. What did we say? Capital D, exactly. So capital D is the differentiation function. So what do we pass differentiation function? What do you think? F of x. And how would you type it in here? F of? Yeah, so no underscore, because f of x has already been defined. And we're going to do comma, because the differentiation function wants the variable with respect that you want to differentiate with respect to, which in this case is x. So we do f of x, comma x. Shift enter. So, is that the correct derivative? Yes. Do that one in your head? Yeah. Pretty easy, right? What's that? The derivative. It is the derivative. F prime. So MMA has a cool way of handling that too. How do you think? Yeah. F prime of x. Shift enter. Same result, right? What if I wanted to store this in MMA's memory as something? Well, I could call it something. Is that a function? Absolutely, right? So if I wanted to store that in MMA's memory as a function, let's call it DER. Let's call it dirf, meaning derivative of f, okay? That's my shorthand. Again, you may come up with something different. You can call it df if you want to, right? It's fewer characters to type, right? But again, you need to develop your own style here. X underscore equals f prime of x. And I can recall that dirf from MMA's memory, and it knows exactly what function it is. It's the derivative of f. Do you see how this game is played? Let's put a heading in here, multivariable functions.
Just put the
world. Now let's do capital F of, what do you think we're going to put here? X underscore, comma? Say it, yeah, Y underscore. Good. Equals. And I have a function picked out, so let's use, yeah, this is a good one. Let's write it on the board first. Capital F of X, Y equals 30X, Y. Okay, beware the pitfall here. How are you going to code that up? 30 asterisk X asterisk Y. Why do we put that one in there? Yeah, we don't want MMA thinking it's a variable called XY, because that's the way it will interpret it. So here's a good habit to practice right now. Whenever you are multiplying anything in MMA on an input line, always use an asterisk. Okay? At least coming out of the gate. Maybe about mid-semester prog when you get a little proficient in things. Yeah. Maybe you don't need to use it all the time, but whenever you're doing two variables in an equation that multiply with each other, you have to use the asterisk. That's why it's a good habit to get. Seen that pitfall a lot in DI.
How do you do that thing again where it like converts to just like basic writing? It's like, so we did write the meaning. Like you start typing something, it's not all blue.
Which part is that? The italic?
the comments.
Plain text. Okay, yeah. Yeah, a little plus tab on the left. This guy right there. Okay, so can we evaluate this guy, Amy? Sure, of course. Let's evaluate it at something simple. 1, close bracket. And maybe we can evaluate it with some variables that we've already defined. How about, you don't have any anymore. We have a C. How about B and C? Yeah. How about this? Let's do f of, let's evaluate it at b and m. Oh my gosh, m is not defined, right? So what do you think MMA does here? It still substitutes this in for y. It just doesn't know what it is. Yeah, because it has no definition. Beware of that as well. Okay, let's do another function. Let's do one with a square root. So let's try function capital G. And I'm going to make this a function of the variable t. T underscore close bracket equals square root function is sqrt. Capital S, because it's a function. If you want to go to the math palette and select the graphic that looks like this, it's a square root with a little box on the inside, with a shaded box. That's on the basic math palette. You could use that. You click on that, and throw that here on your input line. Welcome to use that as well. Let's do a function 3t minus 1. So we do 3. Yeah, you got to get inside the bracket. That's good. So 3 times t minus 1. So that's square root function. Your independent variable here is t. There may be times when you want to use t, right? Like that, right? Okay, so we've done, let's see, we've done differentiation. Let's do some work on vectors, because you guys just clicked on over vectors. So I put a little heading in here, vectors. One face that. Go back down to another input line. So let's define a vector. Let's define a vector 2, 3, 4. Let's call it V. Okay, so how do you write vectors in calculus?
Squiggly brackets.
I hear square brackets, squiggly brackets, but when you write it on paper, and the way you will write it on a GR is using angle brackets, right?
Yes.
Okay, so let's try that here and see what happens. So angle bracket 2, comma 3, comma 4. Close angle bracket. Shift enter. No. In fact, you got yellow and red. Yellow and red, not good. Right? Means you're doing something wrong. What are you doing wrong? Well, the things that are highlighted yellow and marked red. So that is the incorrect notation. So in Mathematica, we use curly brackets. Word of caution, do not ever use curly brackets when you're writing down vector notation on a GR. You'll probably get it wrong. Am I correct?
Yeah, we would not get that.
Yeah. So be careful. Not everything in your world of Calc 3 is, the notation is not a word away. So be careful there. Right? But we've got the vector we can follow. 2, 3, 4. Let's define another vector. let's do U. Let's do -1, 6, 9. Like that. How would I know if those two vectors are parallel? Let's what?
If there's multiple or.
Okay, one is a scalar multiple of the other. So this is your first introduction into what's called the solve command. Okay? So, or the solve function, sorry. We're going to use the solve function. So mathematically, what would this look like? You're doing something like this, right? Like u equals some constant c, right? Times, what did I use, u? Yeah. Right? Like that. If there's a value of c that's scalar, there's multiple, then we know that those two are equal. So how would you do that here? Okay, the solve function is going to solve an equation for you. Right? What equation do we want it to solve? We wanted to solve this equation for c, right? So we would set up this equation in MMA. So we would say u double equals, two equal signs, c times v, comma, c. Now let's stop for a minute and examine what we just typed in here. Solve once an equation or equations. We actually solve multiple equations simultaneously with this. But here, we just wanted to solve one equation for c. U and v are already defined. That's good. We use a double equals here because single equals is used for assigning things into Mathematica's kernel memory. And that's not what we're doing here. We're saying this is an equation. We are not assigning u c times v in kernel memory. We're telling you this is an equality that we want to examine. So what solve means is an equation. Here it is. Double equals sign. Okay? You give it the variable that you want to solve for. In this case, we want to see if it exists. Okay? So did you do a shift enter? What did you see?
Because we already defined C. Right?
Ah, we did. Good catch. Look what happened. Yeah, we already defined C, right? So it's not a valid variable. So it's basically saying, I can't solve this because C is a value of 20. Right? So we need to use something else. What would you suggest we use?
A.
Okay? Is that your suggestion?
A.
K is in Clune Arena? Sounds good. Oh, let's use K. Okay. Okay. So what would you conclude about these vectors?
There's no solution.
No solution, so they are not parallel. Yeah. Exactly. All right, let's do a quick example. So we got 2, 3, 4. Let's multiply that vector by 2. So we would have what? 4, 6, 8. So let's do W equals 4, 6, 8. So we'll do the same thing again. So we'll do V double equals K times W. Okay. Now, right? They are parallel, right? What is the scalar multiple of the other? Okay. That's one example of how to use the solve command. All right, I want to take a few more minutes and show you a couple more things. So vectors, what have you learned about vectors up to this point? Okay, 2 ways to multiply vectors. A dot product and a cross product. Okay? Do you think there's an MMA function for each of those?
Yes.
Yeah. What do you think it's called for the dot product? Okay, so let's do U and P. Okay, so notice you don't need to put a dot between the U and V. You just do commas, U, comma, V. Cross product. Cross product give me a scalar or a vector? Vector. -3. There it is, the vector. Okay. How do you make a unit vector?
Normalize.
Okay, you divide by what? What's the count 3 function? What's the count 3 operation? Take a vector, you divide it by magnitude. Okay. Yeah, there is a function called normalize in here. So if we want to normalize the vector, let's say u, get you better, that's how we produce a unit vector. You could cut that brute force away and divide it by its magnitude, that would be fine. Right, so there is a function called normalize.
So normalize is to take the magnitude.
Takes the magnitude and divides the magnitude into the vector.
Is to take the
Yeah, it creates the unit vector.
Oh, shit.
What's happening? Losing,
Normalize makes the unit vector.
creates the unit vector. Absolutely. What if I have a vector that's a function like this one, if I can illustrate it as the vector equation of a line that is a line of intersection between two points? Well, it's actually pretty straightforward. Let's just do that. R of t, it's a function of t, right? So I'm going to do t underscore square bracket equals curly brackets, right? Like so. So I'll have 1 plus 5t. And minus 2 times t. And my z component is minus 2. And because of the way I've defined this, I can evaluate that for a given value of t. Right? So let's say, we just do it for t is equal to 2. So it's simple. They don't position vector in it. Just see that, right? Well, I use for that. Okay. Vector function, let's see. So if you just want the magnitude of the vector, there is a function called norm. So if we want to know the magnitude of u, and maybe I want to define that in MMA memory as mag u. So mag u would be norm of u. Now, one thing to be aware of, this is just to get it on your radar. The norm function works really well when the components of the vectors are numeric values. It's not all that great when you use it for vector functions, like on input line 56. And what I mean by that is we can just try it. So let's do the norm of R2. Right? It starts getting a little bit ugly. It's throwing out these ABS things, right? And when you start working with a little more complicated vector functions, and you start using the norm function, it's going to get kind of messy. So what I would encourage you to do is find the magnitude of that R of t vector. Just brute force, right? So magnitude is the square root of the square, the sum of the squares of the components, right? Okay? So beware of using that with vector functions. Is that? Yes, it is. Absolutely. So I want to go back to the solve equation. We'll do one last example, and I think we'll wrap it up. We'll go back to the solve equation because I did mention that you can use the solve equation, solve function, excuse me. You can use the solve function to solve simultaneous equations. So let's do that. And let's assign our solution here into a variable called MySOLN. And the equations that we want to solve simultaneously are the following. Let's go back here. Let's do something fairly simple. Y equals 2 minus x. And 5 equals x minus y. So we want to find all values of x and y to satisfy both of these equations. Right? So we want to pass this equation and this equation to the solve function. We want to tell the solve function what variables we want it to solve for, namely x and y. Okay, so how do we do that? Let's code it up. Let's type in the first function, y is equal to 2 minus x. So y double equals 2 minus x. And we're going to give it the second equation, 5 is equal to x minus y, by typing a double ampersand, right? A double and sign, okay? So let's type this equation in next. 5 is equal to x minus y.
Doesn't it be double equals?
Yes, double equals. Nicely done. Double equals x minus y. Comma. We have to tell it the two variables that we needed to solve for. Yeah, but be careful. You've got to put those in curly brackets. X, comma, y. Shift enter. What do you see? Beautiful. Now, curly brackets in MMA is what's called a list. If you just want the most generic definition of what curly brackets is, just a list. A list of what? Well, it could be a list of anything. In this case, you've got a list. There, depending if I gave it different equations, there may have been other pairs of x and y's that may have satisfied the equations, right? In which case, there would have been a comma here, and then another bracket of x and y, and so on, right? However many solutions the particular two equations presented. In this case, it was just one solution, one x and one y, which is fine. So now these values are stored here. So if I type out my SOLN and hit shift enter, I see what is stored in my SOLN. There's a way to use that in a previous multivariable function that we defined. Remember this guy? 30xy? So there's a way to take those, substitute it in to this function and divide it. Right. How do we do that? Here's how. F, x, comma, y. / decimal point. MySOLN. So / decimal point means replace. Take what's on the right, replace it, or take what's on the left, replace it with what's on the right. So what's on the right has an x value of 7 halves, has a y value of minus 3 halves. So shift enter. What do we see there? There it is.
What is the / decimal point?
It's a replace command. So if you want to experiment with that a little more, do it. You're going to use it a lot. Right? You'll be using it a lot. So go to the Wolfram help, right? And at the top bar, type in /dot, hit the search bar and see what comes up. You'll see lots of things. If you want to clean that up a little bit, we'll end with this. You can clean that up a little bit. I'm going to copy this back down on another input line. And I'm going to do this. I'm going to do a double bracket 1. And then I'm going to do double / capital N. So what is this additional stuff here? This stuff right here, the double bracket 1 says give me the first element in my solution list. Okay, that first element is x7/2, y minus 3/2. So again, if there were other xy pairs that were solutions, it would have been a list, right? And if I wanted the second pair only, I would have put a 2. And if it were the third pair I wanted only, I would have put a 3. If I wanted all 3 of them, I would have just left everything off. And would have spit out all the solutions in the form of a list. And what does this do? Can you recall that?
What's that?
Turns into value.
So that cleans things up a little bit, right? That basically gets rid of those outside curly brackets there, and then of course double quotes. Yes?
How do you use like your last answer and then an equation or something?
Use the previous answer in an equation.
Yeah. Like if you wanted to multiply that number by 2.
This number
Yeah.
by 2. Okay, I can do the following: 2 times out 63.
Okay.
What's that? Yeah, we can. Right, we can use the percent as well. Again, the percent is going to recall that previous. Let's do double percent because I want to go up to output 63, not 64. What's that? Yeah, absolutely. Yeah. All right. So Dr. Stanhope's got a reality check for you here this semester. It'll be really good for you to see.
Okay, you remember how we used Calplot 3D to plot those two planes and then a line of intersection between them? I just want to show you what that would take to make that happen in Mathematica. So this is why I don't recommend using Mathematica for visualization. If you wanted to make that exact thing we did happen in Mathematica, this is all the stuff you have to type in. If you were missing one bracket or one comma, or didn't remember something, okay, so that's why Calculus 3D is pretty friendly. Right, but Mathematica is a tool that we're going to need in this course. It's our computational tool. We've seen a lot of nice ways to use it, so keep practicing. Your question?
Yeah.
Anything else you want to say?
Make sure you sign the sign-in sheet before you leave, circulating around.